Welcome to this episode of Energy Radio, a podcast by CEM Engineering with the goal of giving you the knowledge and the tools and the power to manage your energy. Welcome to this episode of Energy Radio. Today I'm joined with our very own Lisa Barber and a very special member of the energy community, a member of what I call the Martin Lensink Quarter Century Club. That's a group of people that Martin has known for 25 years or more, and I think Akil Zaidi from Enbridge fits that category. So Akil, welcome. I'm going to ask you to kind of introduce yourself, but first you have a little commercial you have to do first, right?
Yeah, well, thanks, Matt, and thanks, Lisa, for giving me the opportunity to come here and present some of my views.
Yeah.
And, as you said, it's not even quarter century with Martin, it is more than that. So just want to make a disclosure that whatever I'm going to talk, I think those are going to be primarily my personal views, not of Enbridge. As you know, I work for Enbridge Gas.
Yes.
Has been with Enbridge Gas and Combined Union Gas for about 30 years now.
Wow.
So a lot of I have my own views on certain topics, and so just want to have that disclosure there.
Perfect. And
would be my views, and obviously, a lot of those views are shared by Enbridge, but just want to be sure that these are just for disclosure would be my views. So
understood, and we invited you because we want your views, so this is perfect. This is great.
Thank you.
Can you give us a quick kind of summary of, kind of your career arc in the energy space in terms of, how you get your start in engineering? Somewhere along the lines you run into Martin, but kind of a couple nuggets of what you've done, just so the people who are listening get some background on, this pretty impressive career that you've had in our space, really. Yeah,
because I have been around for some time, and so I could spend a lot of time on
Sure.
that, but I would be brief. So a lot of time, I think a lot of people don't know that how I started my career, which is very new now, but it was new about in 1981.
Yeah.
So when I graduated from University of Manitoba, I worked in solar energy.
Wow, really?
Oh, wow,
really?
And I worked for 4 or 5 years in solar energy.
No kidding.
And that's all what I did.
Wow.
And
Was it solar PV or solar thermal? Or?
no, actually, what is interesting that at that time, we thought that solar thermal is the one which is going to make an impact. Solar PV was just starting, and wind was also sort of at infancy stage, both of these technology, but solar thermal was very advanced.
Yes.
And Canada was leader at that time in solar thermal.
Yes.
So a lot of work I was working with a consulting engineering firm in Winnipeg, and we had a very big contract with the National Research Council,
Okay.
which was doing a lot of work in solar thermal.
Wow.
And we were collaborating with the University of Waterloo, who was developing, actually the person who was involved, who set up the system engineering group at Waterloo,
Okay.
Professor Chandrasekhar.
Okay.
So it was a core group. We were consultants, NRC was involved, University of Waterloo. And a lot of work we were doing was feeding into Canadian contribution to International Energy Agency.
Oh, really? Oh, wow.
Yeah,
So this
so-
wasn't just local. This was kind of all over the world.
It was big. So,
Yeah.
So that's what I did for 5 years, and did a lot of exciting work. And that's where my passion, just the work I had done in heat transfer, combustion, fluid flow,
Yeah.
energy, really fitted very nicely.
So those early years really set you on the trajectory of the rest of your career.
Exactly.
Is that-
yeah,
is that fair to say? Yeah,
exactly.
yeah,
And
yeah.
all
You
the
graduated
excitement.
with a degree from Manitoba in mechanical engineering specifically, right?
Right. Yeah. So I did my master's from University of Manitoba, but I did in heat transfer and fluid flow. So that's got into, at that time it used to be also called and still called energy engineering. So it really fed nicely into my career in the energy sector.
Yeah. So where do you go from the consultancy then? Then you go to
yeah,
NRCan?
No, so what happened is then the solar industry collapsed, not only in Canada but all over the world.
Yes.
What happened, our projections at that time were that the oil prices will go to $40 or $50 a barrel. What happened, the oil prices plunged to single digit.
Single digits,
Yeah,
wow.
it went
Okay.
down to like about $8 or $9. And then there were changes politically also due to that. So the whole work which was being done, it just collapsed. And as you know, consulting engineers, if you don't have work, you're out.
Yes.
So we were 20 people at one time
Yeah.
working on solar,
Wow.
and then it dwindled down to 0.
Yeah.
So that's where I changed my career a little bit.
Okay.
Worked with another couple of consulting engineering firms which were very specialized in research and development.
Okay.
Got exposed to the boilers, condensing boilers, which were just starting in 1986.
Okay.
So did quite a bit of work on the development of condensing boilers and the whole condensing technology.
And are you working with OEMs directly then? Like.
No, actually, I had been working more on the technology development side.
Okay. More R&D then.
Yeah, so there was a company which has got the manufacturing rights to build the condensing boiler from Canadian Gas Research Institute. So I worked with that company, Admic Controls, which was building actually condensing boiler.
Okay, cool.
And that led me to, which is now Enercan.
Yes.
That used to be at that time Energy Mines and Resources.
Right.
And that is going back like in 1987.
Okay.
And at that time, the federal government used to have regional offices in each province. And those offices were called Conservation and Renewable Energy Offices. And
really? This is late 80s.
that is,
we're already using that nomenclature.
We are now looking at about the late 80s.
Yeah.
And so I was in the Ontario office of Enercan, let's say.
Cool.
And we were doing some very exciting work. We had a program was called Ener Demo. So it used to fund the demonstration of new energy efficient technologies. And that's where I met Martin.
Oh, really?
Oh,
okay.
Cool.
That would be sometime in 1987 or 1988.
Okay.
Wow.
And was he was developing some technology and like only Martin can do, he came to you looking for some kind of government funding?
No, so what happened is he used to work, I think, with Union Gas at that time.
Yes.
So he had a project either with a greenhouse or with Heinz. I'm forgetting which one. I'm pretty sure it was with a greenhouse for a CHP.
Okay. Yes.
That was the first one.
Yes.
So he approached our office for incentive and for funding.
Okay.
Really?
So that's where I met Martin.
Okay. And
in
did he get the money from you?
It's
an important question.
Probably he did. I can't recall now. But so
He's in the building. We can check.
Yeah, so he can testify. You know.
That's right. That's right.
What I'm saying is right or wrong. So that's where I met him.
Okay.
And so he had been passionate about CHP since then. You can see, and I had been passionate about CHP since then.
Okay.
So that's how. And the rest is history. So we followed each other.
That's great. That's a great story.
Yeah. So
Well,
I've known Martin for like 30-some years.
And Lisa's heard the story many times, but he always says he fell in love with his wife in 1978, and he fell in love with Cogen in 1986, right?
So 1986. So
that's when he met you.
Wow. We met in 1987, and
there you go. The rest
so
is history.
our love affair goes through.
Yeah, that's right. That's right.
For CHP.
Awesome. And somehow you transition then to the gas side of the business.
Yeah. So what happened is in 1989. The federal government decided to shut down all these offices. And when they shut down all these offices, then I moved to the gas industry.
Yeah.
In 1989.
Okay.
So just to give a quick history, that right now there is only one gas utility in Ontario, Enbridge Gas Inc. At that time there used to be three.
Okay.
One was Consumer Gas,
right.
Union Gas, and ICG. So ICG used to serve eastern and northern parts. So all the pulp and paper mills and everything, that was ICG. So I started with ICG.
Oh.
And we had our senior executive at that time really had the vision that they wanted to have people. They set up a new group. They wanted to have a group which can provide technical support to their large industrial customers to help them improve their energy efficiency.
Wow.
So
what vision, hey? Like to see that that could be a service that the gas utility could provide.
Yeah, and there were no energy efficiency program, there were no incentive, but they had the vision that we need people who really need to know about the latest technologies.
Yeah.
And we bring those technologies to our customers or help our customers to improve their energy efficiency. And that's where I was telling you that I have tested close to 500 boilers in Ontario.
That's amazing.
Hands-on.
Wow. Yeah.
That was all that service, and in that process I've tested gas turbines, reheat furnaces, and lime kiln, you name it. So
Amazing.
yeah, so then ICG became Centra Gas.
Okay, yes.
And then Centra Gas was merged with Union Gas.
Yes.
So all those years, for 17 years, I was in that transition, essentially Union Gas. And then in 2006, for family reason, I had twins. I think a lot of people know. They were growing really fast.
I didn't know that. Okay.
Yeah.
Cool.
I think people like Martin, they know quite well.
Yes.
And they were growing fast, and I used to travel a lot.
Right.
Because I was covering whole Ontario for Union Gas. So just for that reason, to stay closer to the family, I made the switch and joined Enbridge. And now it is all back to
one big happy family.
One big happy family.
So
now it is back to Enbridge.
Talk to me a bit about, so you fall in love with the same woman as Martin in CHP, for clarity.
Right.
So you fall in love with CHP in the late 80s. I mean, here we are now, what is it, 25 years later, like we talked about. The here and now, like what have you seen change in the CHP space? Like some of it's probably the same, and there's probably a lot of change.
Yeah, I think it would be great if Martin, before he completely retires, if he can write a book.
Yes, exactly.
On that about the CHP, that how it has gone, like what is the past, and although it won't reflect what the future is, but one thing is, which is, I'm pretty sure that you would agree, and I'm pretty sure that Martin would agree, that CHP in Ontario has been always driven by the government policies.
Mm-hmm.
That has been the biggest driver. So in early 90s, Ontario Hydro had a program which was called NUG, on utility generation. And through that program, they provided some very nice mechanism where investors can come in and build 100, 200 megawatt facilities and connect those thermal loads to the host facilities.
Okay.
And so, for example, ICG was the first one who built 110 megawatt CHP in Fort Francis.
Okay.
And it was connected to a paper mill.
I see. Okay.
So these are the projects like that, and there were quite a few these big projects.
And it was largely driven by third-party investors who would build it for a steam host. Is that basically how?
Exactly. Third-party developer. They had a 20-year contract. It was very simple contract. That if you're an investor, you're putting your money. You know how things are going to be for the next 20 years.
Yeah.
Right.
And that's how a lot of some very good projects got built through that program. So that was in early 90s. Because at that time the predictions were that there would be a shortfall of electricity supply on the supply side.
Yeah.
And then at once, I think it was in mid 90s that it turned that there is going to be surplus, and at that time, that program came to an halt.
Right.
And at once, actually, there was quite a bit of political environment or policy environment discouraging CHP.
Why exactly at that point?
Because I think because if you have an oversupply,
right.
you don't want to. If people are going to continue to build CHP, it would take away
So
the load.
different than a piece that we're going to come to in a minute. At that point, it was purely a supply, supply versus demand conversation from electricity perspective only. Yeah.
Exactly. Yeah. And we used to joke, and I'm pretty sure Martin knows that. If you're a very big industrial facility and you want some special incentive or special rate, you just show that you're really interested in putting a 200 or 300 megawatt CHP. And then you will get really.
Right.
And there was one consultant who used to offer his services that if you want to reduce your energy costs, let me do a feasibility study.
As really a pitch to the government to get an anti-cogen rate, basically.
Yeah, actually that's what we used to call
anti-cogen
rate. And that stayed, I think it was in late 90s. And then things changed again, and then, as you know, there was a program called CHP RFP.
Yes, I remember that.
That there were certain projects, so there was a process for RFP, so certain CHPs, big CHPs, I think including Thorold and the one at a couple of others, they got built through that process.
Right, yes.
And then came ChipSOP.
Right,
And then some projects got built through ChipSOP.
Yeah.
And I think that is going to take us to early 2000 sometime.
Yeah, early mid-2000s.
And then the whole thing got stagnant for quite a few years. And then all the activity we saw starting 2014, 15.
Yep.
And that's when ISO and actually Ministry of Energy at that time, they started to treat CHP as part of their CDM strategy.
Right.
As energy conservation. So the moment it became part of ISO's or LDC's CDM program, that's where it really took off, because then the incentive, 40% incentive was there, and you know very well that that incentive, what it did. I think there were probably like a couple of hundred projects at least.
I would say, for sure. And I mean, we're cleaning up the last kind of batch of those now, right? But even that had fits and starts. I remember when I rejoined Martin, the program had come out, it was announced, it was at that time 70% of capital was the cap. It was crazy.
Yep. Mm-hmm.
And then everybody's like, oh, time out, shut it down. And so at the time when I rejoined Martin in 2013, there was a moratorium on, the program was still there, but CHP was not an eligible technology. And then, so nothing had yet been built. Everything had been studied, but nothing had been built. And then I think late 2013 they lifted that, and so Polycon, the Magna plant, and Toyota were one of the first couple ones to finally, get that, and it was reduced to 40%, which is still a big chunk of change,
70%,
right?
that's
It was, and 70% always applied to like waste energy projects, right? So, where's your perspective, Akil? You've tested all these boilers. You're clearly playing up here in your headspace in the policy, but also you have the chops to play in the technical space. What have you seen change in the CHP industry on the technology side? Are there any big? Some again has stayed the same, but what's intrigued you about how that technology has changed over the years?
Yeah. So on the gas turbine side, the biggest change was the NOx. NOx used to be a big issue for gas turbine because of the high temperature.
Yeah.
So the low NOx technology came in, and the dry NOx, dry combustors.
Yes.
So that, because before that, actually, if you look at, there were a couple of projects which were done. We're using a steam injection or water injection to.
Yes.
Actually, there was a cycle which was developed at that time called Cheng cycle.
Yes.
Just for that reason, to achieve not only the NOx but was augmentation as well.
Yes.
And we have one CHP system running on both.
Okay.
In Ontario.
Oh, really?
Yeah.
Okay.
So that was. So then that changed to this dry NOx combustors. So that has been a big change.
Yeah.
The second one is the overall efficiency increase.
Yeah.
On the gas turbine side.
Yeah.
But there has been quite a bit on the recip engine. I mean, that's one area where the electrical output from those engines have just gone up, all the way up to like 45%.
Yeah.
And then the big thing which also happened is the recip engines at that time, a lot of those used to be on-site installation. Now it is all packaged.
Right.
So
The delivery has changed,
the delivery
right?
has changed quite a bit. So a few things have changed. On the technology side.
Yeah, that perspective, I love to hear that. So thank you for that.
Yeah.
And I think we're probably one of the only podcasts out there with a reference to the Chang cycle. So we need to put that in the title of this
That's
episode.
right.
That'll gravitate a lot of people. Let's go back to the policy side. So you made a great reference that the surge or the peaks in CHP development have been policy driven, but my sense is that the valleys in that are also policy driven, and we're in a current policy climate of kind of carbon is a swear word, right? Is one of the phrases that we use. But you have a bit of a different stance on that, I think, in terms of where CHP fits into this broader emissions discussion and how you see it potentially as a tool for emission reduction, as opposed to you're burning gas, you're bad. Like, talk to us about your perspective on that whole atmosphere.
Well, I'm glad that you asked that particular question, because that is the topic where I have been very passionate about for the last, at least for 3-4 years.
And we love that you're the champion of it, by the way.
And we have done a lot of work, and so what happened is the GHG reduction from CHP, again, that's from my personal perspective.
Yes.
I think it is not a technical issue. Technically, anybody who understands that what CHP could do for GHG reduction is a very strong argument. So it's not a technical issue. I think it has been a political issue. And the political issue, exactly what you mentioned, that if you have a backdrop of electrification or GHG reduction, and looking from this lens that anything which is burning fossil fuel is adding GHG.
Yeah.
So if you look at from that perspective, then you would see that it is adding GHG emissions.
Right.
But then if you look at technically and from a bigger perspective.
Can you walk us through that story for a minute? I think it's important for those who are listening to hear the technical rationale, because I love it personally, but I want to hear from you, for the benefit of our listeners, that technical explanation.
Yeah, so I think because I can speak at a higher level, because as Lisa has seen my presentation and you have seen,
yes,
I can explain. I'm a techie, so I can explain it very nicely on a chart, on a whiteboard, and on my slides. But just on speaking, I'll keep it at a high level. So really, what it is, so when you put a CHP at a site, what it is doing, it is displacing the gas which was burned in a boiler. So that is one aspect. So it has reduced the gas in the boiler, but still it is an incremental gas to produce electricity. So that's where the debate comes. So there is an incremental gas, it is producing electricity. If you just stay within that boundary, then because there is an incremental gas consumption, because of that, then there is going to be GHG emissions.
Right.
However, if you look at beyond that electricity which is being produced by CHP, it is reducing draw from the grid. Like, it is going to have an impact on the grid.
Yes.
So then we have to go to the grid. We have to see what it is doing to the grid. And it is no different than any other technology of CDM technologies which are being put in the same perspective.
Yes.
The whole concept of electrical energy efficiency program is that if you reduce let's say you change your light bulbs, it will reduce your draw.
Yes.
It will reduce draw from the grid.
Right.
But we're in Ontario. I'm going to play devil's advocate. We're in Ontario. We have a very green grid, don't we?
Yeah, so we will get to that.
Okay.
But just on this one very quickly, so where I was going to get it, so if we look at that the CHP is now displacing, let's assume for a minute before we get to that question, and it's a very interesting one, that it is reducing draw from the grid. And now, where that electricity is coming from, which it is reducing. Let's say we have a CHP of 1 megawatt. It is displacing 1 megawatt from the grid. Now, where that 1 megawatt is coming from? So let's assume for a minute that it is coming from gas-fired generation.
Right.
So then you can look at that CHP is, could be anywhere from 75 to 85% efficient.
Yes.
It is displacing the electricity which is being produced by gas power plants, which are at best probably are about 45%
Right.
efficient.
Okay.
And we are talking about high reading values, just to be sure. So that's where the efficiency comes in. And when we see that there are the efficiency gains, then there got to be GHG reduction. Now we will get to the second question. So the first part was that, so if we agree that CHP has an impact and it reduces draw from the grid. So I think everybody agrees on that.
Yes.
Then the second question comes exactly what you mentioned, that, okay, so where is that reduction? Our grid is so clean, so how it can have an impact on
Right.
the GHG reduction? So when you look at, right, so are we good so far?
We're good.
You're
Yeah.
good, yeah.
We're good.
Okay, I just want to make sure that,
Yeah.
I make it clear without using slides or
Sure.
or the whiteboard.
That's good.
So when you look at our energy supply mix as it is today, we have base load of nuclear
Yes.
of about 10,000 megawatt. Then the next layer up, which is for the base load, is hydro. There is about 3,000, 3,500 megawatt, which is always base load.
Yes.
There is another about 1,500 to 2,000 megawatt, which changes depending upon the demand
Of hydro.
of hydro.
Okay. Yes.
Right? So that's where our grid is clean. The next layer up is renewables. Although the slice is very small, but it is still there.
Right.
Now, the renewables are intermittent. When the sun doesn't shine and wind doesn't blow, like a day like today, for example, we don't have that source of energy.
Yes.
So that cannot be used to meet our fluctuating demands
Right.
hour by hour. Now, when you look at the last layer up in our supply mix is gas-fired generation.
Right.
And that gas-fired generation could change anywhere from 200 megawatt to 5,500 or 6,000 megawatt,
Wow.
Okay.
depending upon our demand.
Right.
And another fun fact, we have about 10,000 megawatt of installed gas-fired generation. And there is a reason for that. Because if we didn't need gas-fired generation, then why would we have 10,000 megawatt
Right.
of installed
Right.
capacity? And we do go up to, let's say on a hot summer day
Yeah.
or on a very cold winter day, especially, we could see gas-fired plants running close to 5,000 megawatt.
Yeah. Yeah.
So far so good, right?
Yeah.
So now let's see that 1 megawatt of CHP comes on, and which of these sources it is going to have an impact. It's not going to have an impact on nuclear because that is base load, because you can't control it
Right.
for
Right.
most part.
Right.
It won't have any effect on most of the hydro, although
Right.
it would have effect on some. But the biggest effect it is going to have is on the gas-fired generation.
Okay. Yeah.
So now, if it is going to displace that 1 megawatt from the gas-fired generation, so now these gas plants don't need to produce that 1 megawatt
Right.
at 45% efficiency.
Okay.
That 1 megawatt is produced by CHP on site at about 75 to 85% efficiency.
Gotcha.
So that's where the GHG reduction comes into the
Right,
play.
which I guess would mean that in future, really, we're going to be looking at even greater reductions on that front then, because obviously, although Pickering has been extended, when that comes offline, if you have natural gas plants that are operating to provide us with our electricity, CHP could even provide a greater benefit at that point, right?
Yeah, that's a very good point what you're raising, Lisa, because the Pickering looks like we don't know if it has been extended or not, but let's assume that it gets extended. But there is also the other nuclear fleet which is going through the refurbishment.
That's right.
So at any given time, like let's say 25 or something, you could have 2,000-3,000 megawatt of shortfall.
Right.
Now we know that renewables are picking up and they could fill that gap, but the only way it can add the resiliency and to fill that gap, our storage technology has to develop
Right.
to store
Yes.
2,000 megawatt of,
Yeah, right.
of that energy, which can be used
Yeah.
to meet the fluctuating demands.
Right.
So what we can see for now that that these gas plants are going to run at least at the same level, if not more.
Huh. Yeah.
So, and that's where the concept of this marginal
Right.
power comes in and marginal emission factors.
Right. Okay.
And that's where the concept of flexible CHP also comes in.
Right.
That flexible CHP can play some really important role to reduce then GHG emission, because flexible CHP could displace some of this marginal, what we call marginal power, which is the gas-fired generation,
Okay.
or portion of the hydro generation.
Okay.
So that's what we call marginal power.
Okay. Okay.
Yeah.
Interesting. Wow.
And that's where, we could have some discussion if we have time about the emission factors.
Okay.
But I'll let you
Yeah.
ask
No,
another question.
I'm
you
thinking
have.
of this a cloudy day where the solar has dropped. We don't have much solar production today. Today's a good day for cogen. I'm always thinking of marketing, and the slogan that comes to mind is "Stick your CHP when the sun don't shine." So if the Honorable Ministry of Environment and whatever they're calling themselves these days walks into this room right now, what's your, maybe it's these marginal emissions factors, but does he walk in and you say you got to change it, you're wrong? Like how do you, where do you see this? Because I think that the province has adopted a different approach, and they don't really know what they're doing from a carbon perspective, but if that person walked in today, what would you say to them? Like, how do we get that methodology adopted? Because it makes perfect sense to me. It's the right way to look at it. How do we move from here to get it as a policy framework?
Yeah, so that's where I was saying, it is a political will.
Yeah, right. Okay.
And technically, I don't think that there is much dispute on this concept. Now, how do you prevent and how do you adopt into your policy when there is so much activity going on about electrification and non-fossil fuel generation? So I think that's where the ministry or the government really need to figure out that there is a reality on one side.
Yes.
That we need to keep the we need to still heat the homes, and we need to keep the lights on.
Yes.
And keep the manufacturing going in Ontario.
Yes.
And we need to keep all these energy costs as low as possible.
Yeah.
And at the same time, we need to reduce GHG emissions.
Yeah.
And I think if by somehow the policymaker can accept the fact that CHP reduces GHG emissions, then it could fit into their framework, and they can start accounting for that how CHP is making an impact. And it would have brought, I think, as you know very well, that just because of this confusion about the policy, we have lost, I would say, maybe about 20 megawatt.
Oh, I would agree. I mean, there's a project. I'm pointing in the wrong direction. There's
Yeah.
a project at Western University that
Yeah.
should have gone ahead. Policy killed it. I mean, there's other projects.
But I know there are a couple of others.
Yeah.
So essentially, we have lost about $50 million investment,
Yeah.
Yeah.
at least in Ontario, just because of that policy.
So here's an interesting question that just came to me. There's a couple. If it's all a policy discussion, there's the policy of emissions reduction. So that's kind of one pitch. There's a pitch around resiliency, because I really believe strongly in that piece, and then there's a pitch around economic investment. If you pick, which one do you think is the best? Like, what should CHP as an industry lead with? If that minister walked in, do we say to him, hey, let's do the math on emissions reduction, or do we say to him, hey, we're going to provide Sunnybrook Hospital with resiliency when there's an ice storm, or hey, we're going to invest $50 million, 60% of that is private capital, or all of it's private capital. what do you see as the strongest story for CHP?
I would say I think it is all. It depends. Yeah, because it depends where CHP is going to be installed. Like as you said, if it is Sunnybrook, that's where the resiliency is very important.
Yes.
Or let's say high-rise buildings in Toronto, for example.
Yes.
For the emergency plan and all that. So that would be very important for that. If you are a manufacturing facility, then you're really very interested on reducing your cost. Unless there are some industrials who are very interested not only reducing cost but reducing GHG emissions as well.
Right.
Because of their sustainability index.
Right.
So for them, those would be both factors. And so the cost, we can do the math and everybody can agree that, that's that the cost is. Where the confusion is about the GHG, what are the GHG, are these GHG reduction or these are addition? That's where the government could play a very important role. At least having some direction for the industry, saying that these are the emission factors one needs to use, and then leave it up to the industry.
Interesting.
And we right now do not have an official marginal grid emission factors for Ontario.
We have take all the megawatt hours, take all the emissions, divide by all the megawatt hours, and you get one number, right? That's what we have. And
that is called the average.
Yeah.
So when you look at the average right now, it is very low because it's a very simple math.
Yeah.
So when you look at, let's say, 100 units of energy produced and 90 is coming from nuclear and 10 was gas, let's say, and the emissions from that 10 gets divided by total 100, then your emission is really small.
Yeah.
Right.
So indirectly what it is telling us that when CHP comes on, it is having an impact on nuclear, hydro, everything, whereas it doesn't.
Right.
But people are still using that 30 gram per kilowatt hour average emission factor.
So so that's from an institution, a hospital, university. I get that they're beholden to a provincially mandated emission factor, like you say, the average number, right? But in your experience, when you're working with an industrial, we're very empathetic to industrials who, maybe have one Ontario plant and the rest are in the U.S., right? So they're getting pressure from the Americans to drive down costs. So they look at CHP. In your experience, have those industrials been able to take your framework and use, if they have some sustainability target corporately, have they had success in taking your framework and that marginal emission factor as part of their internal accounting, even though it's not the policy of the day in that jurisdiction? Have you seen people do that, where they use it as part of their internal accounting?
Unfortunately not.
Okay.
Because when it comes to the reporting and all that, then it becomes government policy.
Okay.
And if that policy does not accept this concept of using marginal emission factors, so that's where some big corporations who are very concerned about their sustainability index, they have walked away from CHP just based on that, and I'm pretty sure that you know about those customers. So that's why this policy about GHG emission factor, I think, is very critical. So
well, and it's driving the market to, there's a lot of people now who are, instead of CHP, they're going to a less efficient technology in simple cycle, right? We've done a bunch of projects where, it's a simple cycle gas engine at 30% electrical efficiency, right? HHV, or 35 at best.
Right.
So because of the policy framework, we're actually going in some ways the other way, right? Because we're seeing peaker plants go in industrial sites for GA mitigation, right?
Exactly. Yeah. So when you look at it, that what GA is doing to CHP, and for GA, if some people are installing simple cycle, for example, so now you're adding emissions, and so it is all very convoluted now. So to add some clarity to that, so what we have done, so that was the issue. So we made our presentations to the province a few years ago and to ISO on this concept of GHG reduction. And I have spoken at a few conferences. So the issue used to come into the play that which source of energy or generation is being impacted.
Right.
And let's say gas plants, they run for various reasons, so they may or may not get impacted by CHP. So we engage.
Because they provide other services beyond just energy. And
Exactly.
capacity.
Yeah. So there might be some contracts for contractual obligation. They might run for grid stability, for ramping up, ramping down, peaking. So the whole bunch of things.
Right.
So that was way beyond, what I could understand. So we engage a company called Power Advisory. They're
we
the
know
expert.
those. Yeah.
They know how the grid operates.
Yes.
So we asked them to do the analysis.
Okay.
So they have established, so they have built models now based on the hourly data. And based on those models, they can see that which source of generation is on the margin or what it is contributing.
Right.
Let's say between gas and hydro or even renewables, what they are doing to the emission factors.
Right.
And they have also taken into account, because they take into account import and export and everything.
Right. Okay.
So based on all that, they have developed curves, which is sort of an S curve,
Yes.
that there are times that the emission factor would be very low, depending upon what is the generation, what is the demand and supply. And then there will be times then it would be higher, and then it could be very high.
Okay.
So they have done this hour by hour analysis. So the model is built on, for the last 3-4 years, hour by hour, and then it is projected into based on the last long-term energy plan, which was presented. So they have done the analysis hour by hour for the next 20 years.
Wow.
Wow, yeah.
So we have an emission factor for every hour projecting into the next 20 years.
Really?
So what we have done, we have condensed it into a more practical format where people can use it. So now you can have, so if you install a CHP today, it has nothing to do what happened in the past.
Right. Right.
You have to see what it is going to do in the next 20 years.
Right.
So that's where we consider that what are the factors which are going to be in the next 20 years.
Yeah.
So you can take an average and take all these things into account and come up with an average marginal emission factor.
So is this document that they prepared, is it ready? Is it available out there for people to actually reference?
Yeah, so that's a very good question and very timely, because so the document is it's ready, but we are just going through the final draft, and so in the next few weeks that the document is going to be available for public consumption.
Really? And is that a document that comes from Enbridge? Like, did Enbridge fund this work?
Yeah, so we funded that work.
Really? Wow.
Yeah, so we funded that work, and
Cool.
Power Advisory has done the work. So,
And is there so then do you march back into the ISO office and kind of slam that down on the desk and say, see, we were right? Or what's the next step with that document?
no, so it would be for public consumption,
Okay.
and obviously, it will be available to ISO as well, and then we will see that how it is accepted. So.
And can you give us an early indication? Does it validate the early work that you did?
Yeah, so we have been using those marginal emission factors for a lot of our CHP analysis, and for quite a few clients, not our clients, but our customers.
Yeah, sure.
And some consultants who have come to us and they have said, okay, so what if?
Right.
And then what is very interesting, so we have done so many scenario or different sizes of CHP and different scenario. And if there is a well-designed CHP system, which we all promote, we don't want to see CHP system going at 50% efficiency or
Correct.
60%.
Correct.
If you have a CHP system which is very well designed, let's say anywhere from 70 plus efficiency, and if you use the marginal emission factor, then CHP is always going to reduce GHG emission.
Okay.
Wow.
Yeah.
Wow.
Or at the minimum, it is not going to add any GHG emissions.
Right.
So we have
Very
done
cool.
the analysis for residential, commercial, industrial,
Really?
and we right now we are looking at using those factors. We have put together a case to change or at least present it to the building officials for SB10.
Oh,
Cool.
Because what they're doing in SB10, they used to use marginal emission factor, they change it to average emission factor. And if you use that average emission factor for new construction, you cannot put CHP in any new building.
Okay.
So we have engaged another consultant, Sustainable Building Canada,
Yes.
and there is another consultant who has done Power Gen Sys, Vito, who has done very extensive analysis, hour by hour.
Yes, I know Vito. Yeah.
So we have put together all that case, which is going to be presented to building officials.
That's excellent.
And let's see where it goes.
Wow.
And we are demonstrating, we have used 5 examples, that in every example, if it is a well-designed CHP, and that's what we promote. We don't want to have a less efficient CHP.
Right.
Then CHP will always have an impact on GHG reduction.
Now, when we talk about a well-designed CHP, and we're kind of getting into the bug dust, but I'm okay with that. Does that, so the knock we always had as, folks who, love a good gas turbine job, we always took issue with the ISO approach that never counted the duct burner's efficiency into an efficiency calculation. They always drew the box and they kept the duct burner out of it. Do you guys look at that, like when you're saying an efficient, from an emissions intensity perspective, you have to draw you're going to get more efficient steam in, if you're putting in a duct burner, right? Like, does that factor into your calculations?
It has to, because when you look at duct burner is the most efficient combustion you can have.
Yeah.
It is 100% on low heating value.
Low heating value, yeah.
I mean, it's that simple.
Yeah.
Really. You cannot have more efficient combustion than duct burner.
Yeah.
So you have to take into account, because what it is doing, it is improving. When you draw the box, you're looking at how much energy is going in and how much energy is coming out. It is that simple, really.
Yeah.
So you have to take that into account, and the moment you take that into account, then the efficiency of a gas turbine with HRSG, it goes up. It goes into like 70s.
Definitely.
If you don't, then it stays below 70.
Right.
And that is just inherent of the way gas turbine works.
Right,
It is there is nothing you can do. It is a mass machine.
Right. That's right.
You just have huge amount of exhaust coming out, unless you. And then we have done projects where we have condensing economizer to recover even that much energy. So you can bring. I think there are projects we have done together.
Yes.
I think you have done those projects.
Yes.
And then they have been part of our energy efficiency program also.
Yes.
Where you put the condensing economizer and you can raise that efficiency from low 70s to high 70s. You could go up to like 78. I think the highest I saw was close to 80%.
Wow. On an HHV basis.
Yeah, because what you're doing the moment, so now you have huge amount of energy which is being exhausted.
Right.
If you can condense and recover all that latent heat, you're recovering huge amount of energy.
Totally.
So
cool.
So if you take all these into account, it would, based on the emission factors, marginal emission factor.
Cool.
Most of the gas turbine jobs will have an impact on the GHG reduction.
So the overarching theme is let's get the emissions factor on a marginal basis. Let's get the policymakers to subscribe to it, and let's turn down the big inefficient combined cycle plants, or even the CHPs or the simple cycle plants out there. Let's turn those down. Basically, is in short, that's the story.
Yeah, I mean that's where CHP can play a really very important role.
Right.
And
that's before we start talking about resiliency, right?
Yeah.
If you have a dark, day and it's not windy, but you have a hospital that needs power, the gas line's always going to be there, right?
Exactly.
So,
yeah.
Good. Yeah. Let's maybe pivot away from CHP for a minute and stand here looking ahead. What else do you see on the horizon for new technologies in our space? I mean, maybe this rolls into electrification, but where do you see kind of the market going if you have an Akhil Zaidi crystal ball? What excites you about what's coming down the pipe?
Well, I mean, what is because of this electrification? It is very emotionally charged.
Pun intended, right?
Yeah.
Pun intended.
So definitely our the supply mix would change. I mean, there is no doubt.
Yeah.
So there is just so much exciting work which is going on, like from our Enbridge perspective, not only Enbridge, the whole gas industry
Okay.
is really doing a lot of work to see that how we can decarbonize our fuel.
Yeah. Yeah.
And we have so much assets, so big storage, what you can call,
Right.
thousands of miles of pipeline.
Yeah.
How we can make sure that they are fully utilized. So there's a lot of work going on in renewable natural gas.
Right.
That we are trying to see that how we can fill those pipes
Right.
together with natural gas. We can add an RNG
Yeah.
and increase the amount of RNG to decarbonize.
What's needed for from your perspective? What's needed for further increase of RNG? There's a couple in the province, but for increased gas RNG injection into your infrastructure, what's needed to spur
Yeah, so
that?
I think that's where I'll be go out of my comfort zone.
Okay,
I may say
okay.
something which may not make
Yeah.
sense, but at a high level.
Is it
I
a
think
policy thing again?
It's
Yeah.
it is a policy. It's a framework that we all know that the cost of RNG is much higher than the cost of
Right.
natural gas.
Right. Right.
So, for the market to develop to accept that higher cost, there got to be a policy in place.
yeah. Yeah. Okay.
So once you have that in place, so that will create the market,
Yeah. Yeah. Yeah.
and then there will be supply that where this RNG is going to come from.
Right.
That is a secondary issue.
And I know you mentioned Dave Tykerobe, we're going to have him on soon, and this is his bailiwick, but hydrogen fits into that piece too in terms of leveraging your existing infrastructure. Does it not?
Exactly. Yeah.
Yeah.
So hydrogen. So Enbridge is doing one work where we have power to gas
Yeah.
facility, which Dave Tykerobe probably was
He's
very,
mentioned
very
it once or
well
twice. Yeah.
engaged.
Yeah.
So
Yeah.
it produces hydrogen,
Yeah.
and so we are looking at that how we can start injecting that hydrogen into our supply mix.
Yeah.
So
Interesting.
You mentioned electrification being a charged topic. To me, I step back and I say, okay, electric vehicles, that's going to happen. There's some stuff that we may get to a point where we're doing a lot of maybe residential electric heating, but I think there are some people who extrapolate the whole way and say electricity, everything. I mean, where do you see? Because we burn a lot of gas and a lot of boilers for a lot of process heat and a lot of there's some middle ground where we're going to end up, but that whole converting to electric boilers particularly in an Ontario framework, do you see that happening, or is that a kind of crazy dream?
yeah, so I hope that before people start investing into electric boilers, that they keep into consideration a couple of things.
Okay.
and then the policymakers, who are looking towards electrification, also look at rationally that is it possible? I mean, what is doable? I mean, all of us, as I said, I started my career in renewable, and I have been working all my life. I have worked in energy efficiency,
Yeah.
which essentially reduces GHG emissions.
Yeah.
So the goal has been, how we can make things cleaner and cleaner. So, but I also, at my, spending so much time in the industry, I have become a little bit realistic as well. That so we have ambition, which is great, but then realistically, what we can do.
Right.
So just to give you an example about electrification, when you look at, and especially makes perfect sense for EV, I mean transportation, about 45 or big percent of our GHG emissions come from transportation sector.
Right.
Yeah.
So that is the one, what we need to address. But when it comes to resistance heating or producing steam
Yeah.
from electric boilers,
Yeah.
that's where we need to keep in perspective that where that huge amount of electricity will come from.
Right.
Do we have renewable resources in the next foreseeable future? Let's say by 2030, I'll just put a number.
Sure.
Do we have by 2030 sources of electric supply which would provide clean or non-emitting energy?
Right.
I would say probably not,
Right.
for a very simple fact, and that's a fact, that when we look at our peak on the electric grid is about 24,000 megawatt, right?
Yeah, yeah.
I mean, that's what we peak at. If we were to, and if you look at on the gas side, on a very cold day, our system would peak, if you convert it into the same units, it would peak at about 85,000 megawatt. So if you convert everything to electricity and take into account the efficiency factor, and unfortunately what happened is, I'm talking about the air source heat pumps
Yes.
that people talk about, that they have very high COP, so really there is no one-to-one comparison. Unfortunately what happens is, on the coldest day, when that's how you design your system, those heat pumps, most of them, they just run as a resistance heater because the COP goes to 1.
Right, right.
So they are just working like a resistance heating. So essentially, to meet that demand, where will you get 85,000 megawatt? And I don't see that between now and 2030, we can build 85,000, or let's say another 60,000 megawatt
right.
of electricity generation.
Okay.
So I think that's the perspective
Yeah, that's great perspective.
industry needs to keep in view, that if you start investing in these boilers and start converting your heating system, what impact it would have. So unintentionally what might happen is, they want to do it for good cause, but then if all that is coming from 45% gas-fired power plants, and then you take into account 5% line losses, now you have about 40%.
Right.
Whereas gas-fired boilers, they're like 85 in that range. So I think those are the facts people need to keep in mind. And the other part is, when you buy a boiler, it lasts for 40, 50 years, 30 years. And they're expensive. And they're very expensive to maintain. And so we need to keep all these things into perspective before. We need to use the energy where it makes sense from cost and from the emissions perspective.
Right. That's really, you're really helping us focus on the forest when a lot of us get lost in the trees. That 24 versus 85, that's just massive. That's massive.
Yeah.
When I walked in before we started, you and Martin were talking about flameless combustion boilers. Talk to us a bit about that.
Yeah, so as I was saying, I mean, that whole topic of flameless combustion is very technical.
Yes.
And sort of a little bit beyond, although I have done a lot of work in combustion. But to explain that how it works, it's quite complex, so I think I'll keep it at a very high level.
Okay.
And so as the word says, flameless, so you have combustion has no flame.
Yeah.
So to see that, you have to see what creates flame. How do we see the color and shape of the flame? So that all comes that how the air-fuel mixture gets ignited and how the flame gets anchored at the burner. So that's how we see the flame, because the flame is anchored to the burner, right?
Yes.
So with the flameless combustion, really the flame is not anchored. So what happened is, there is a lot of air fuel comes in, it gets recirculated internally, closer to the burner, and it gets preheated to very high temperatures. So what happened is, in a normal combustion, that flame has adiabatic temperature of, let's say, 34 or 3600 degrees F. And right away it gets to that temperature, gets burnt, and we see the flame.
Interesting.
In this one, the air-fuel ratio gets recirculated, and it gets preheated, and when it is at a very high temperature, then it moves along the chamber. And at a very high temperature, when it is moving along the temperature, and that's where it combusts. So when it is at a high temperature and it is combusting, it would combust at, so the flame temperature would be much lower than 34 or 3600 degrees.
So is there more oxygen, more air than in the combustion process in general?
No, it would be the same.
Okay.
It is just that before it burns, it gets preheated at a very high temperatures. And then when it burns further along the way, the flame is not anchored, you don't see the flame. And then it is just burning.
Very cool.
Further down.
What's the advantage? Is it energy efficiency? Is it emissions? Like, why do people Sounds complicated. Why would people go? What's the advantage?
The whole technology got developed based on NOx reduction.
Okay.
Because what happened is there is a very direct correlation between NOx and the flame temperature.
Right.
If the flame temperature is high, NOx will
NOx
be
goes
high.
up. Yeah.
So if you can reduce that flame temperature, the NOx will drop. So in this case, the flame temperature is low,
Yeah.
and so really the driving force for this flameless combustion, which is also called FLOX, was the NOx reduction.
Okay.
That's sort of my understanding.
Yeah. Okay.
It is the whole technology got developed in Germany, and it has picked up a lot.
Okay.
Like when you look at the places like California,
Yeah.
they have single-digit NOx requirement from
Yeah.
combustion.
Wow.
So and there are a lot of other jurisdictions
Yeah.
which require
Yeah.
very low NOx.
Yeah.
For high temperature, that's where this technology is becoming very popular.
Cool.
Interesting.
So as we kind of land the plane, Akil, one of the you've seen this whole kind of arc of our industry. You've had your ups and your downs. According to Lisa, we have many younger listeners that listen to the podcast.
We do.
Okay.
Do you have any words of wisdom for somebody who's thinking about, or especially those who've said, "Hey, I want to be in this energy industry"? Do you have some words of wisdom for them that they can take and hold on to?
Yeah, I think I see myself in the same position like young listener would be in let's say in 1981.
Sure.
For me, what was so exciting at that time was working in the solar energy. It
Okay.
was just so exciting,
Okay.
and that built my passion.
Yes.
So we are sort of in the same time frame right now, that the whole energy sector, the energy supply, the sources of energy, the GHG, it is so exciting. There's so many technologies which are coming into the play.
Yeah.
Way
Right.
more than they were in just, at that time was just the solar energy, nothing else.
Right.
Now you're looking at RNG, you're looking at electric vehicle, you're looking at hydrogen, you're looking at the whole decarbonizing and
Right.
and the CO2 capture technology. I mean, there are just so many technologies. So it is going to be even more and more exciting. So if
Yeah.
I was 35 or 40 years ago in that field, which some of the listeners would be, very exciting.
Okay.
So many opportunities.
Yeah.
The most important thing would be, I think they need to see, or if I was able to see at the time, the passion. That what do you have passion for,
Yeah.
and then
yeah.
just go with your passion.
Cool. And
But the opportunities are just tremendous.
yeah.
Yeah.
Yeah. Yeah, and sometimes it takes a couple. You got to try a couple things to figure out what your passion is, right? Like
Exactly,
you don't necessarily know it intuitively. You have to try it. Say, I don't like that. Try something else. Oh, I like that. That
Exactly,
kind of-
yeah.
Cool.
Yeah.
Excellent. Well, Akil, thank you so much. This has been a
it's been
real
great.
pleasure for us. I am smarter for it. That's very clear.
Oh yeah, no, I learned a lot today too.
And so we appreciate you coming down here, and you're a friend of the family, so to speak, of CEM. So thank you very much, and we look forward to continuing to work with you and doing more great projects. So thank you very much.
Yeah, thank you, Akil.